Hey guys, just doing another quick help video for your portfolio of learning for measurement. So today you're working on questions 4 and 5 of surface area worded application. So let me highlight that. You're doing this and you are doing this one. So to be able to, you can do this one already because you have all the formula needed for that. It's just rectangles and triangles, but I need to help you out and give you the formula for this shape, which is a trapezium. So if we go back up here, area of a triangle, you've had that before, half times base times by height. But the area of a trapezium is a quadrilateral. It's got 4 sides and 4 corners. But what's special about it is it's got 2 parallel sides. These are in line with each other, but one of them is shorter than the other, okay? So A and B are parallel sides, but they're shorter than the other. The last 2 sides, they're not parallel. They point away from each other. Why do they point away? Because one of the sides of A and B is shorter than the other. So the area of a trapezium is whatever A is plus whatever B is, divide it by 2, find the answer to that, and then you times it by the height or the distance between those parallel lines A and B, okay? So that's the formula for the area of a trapezium. Today you're applying that. So this is the one that I'll set you up with. Not give you the answer, but set you up with it. The base and inner walls of the swimming pool shown below are to be tiled. What's the total area of tiles required for this? So you can see this is a problem that maybe a tradie would encounter. We need to know what area inside the swimming pool I'm going to have to tile up. So the first area is going to be the back wall, which is the same as the front wall, which is a trapezium. Area of back is a trapezium, which is A plus B over 2 times it by the height. Now this trapezium looks weird because it's not the shape that I drew here, but it has 2 sides that are in line with each other, one shorter than the other, and then 2 remaining sides. So you can see here, this side is in line with this one, and then it got 2 remaining sides here. So these are the 2 parallel sides. Those are A and B, okay? So how tall is A? It's 1.2 plus B, which is 2. Divide that by 2, times it by how tall is it? The tallness is the distance between the parallel sides. So the distance between that and that, which you're told is 50 meters. So times it by 50 equals, let's do a line there. That's the area of the back. The area of the front is exactly the same. The area of the front is this. So it's going to be 1.2 plus 2 over 2 times by 50 is the same line. Now remember, this is a swimming pool. So we need to do this, the left and the right, and then we need to do this big flat space here, the diagonal line there. So that diagonal line, we actually need to do some maths for that. I'll do that now. I need to do Pythagoras for that because we don't know how long that long side is there. So the triangle to take 1.2, 0.8 squared, 0.8 squared plus 50 squared, square root the base and the inner walls of the swimming pool. Yep, so this is going to be this long side here that forms the base of the swimming pool is going to be 50.01 meters long, which you'll need to find the areas of it. So now Let's set you up for the area of the left. The area of the left is a rectangle. It's 2 by 16 equals, find the answer, squiggly line. Area of the right is going to be, it's 1.2 tall, 1.2 times by how wide? 16 equals another squiggly line. Then the area of the base, which is this thing, area base is going to be a giant rectangle, which is 50.01 meters times by 16 wide, which is, let's do a zigzag line there. So now I've set you up for this. Find the area total, add them all together. Okay, then that's going to be in square meters. Now to help you a little bit with question 5, it's just breaking it up a little bit, but you have the formulae for all of these questions. What is the surface area of the vertical wall? So the vertical walls are going to be this side standing up, this side standing up, the left side that's hidden, standing up, the back that's hidden, standing up, and then these 2 triangles here. This one at the front and the one at the back that you can't see. Those are the vertical walls. You have the formula for the area of a triangle and a rectangle. Area of a rectangle is length times by width. Area of a triangle is half base times height. The surface area of the flat roof section, you're just finding that. The surface area of the sloping roof section, you're just finding that and that side, but because it's Pythagoras, I need to help you out with that. This side is going to be 4, and this is 3. Okay, so these long sides, the slope sides are going to be 5 meters long. So you'll need that to find the area of the sloping roof sections. And then the number of litres of paint needed to paint the roof and walls, given that each litre of paint covers 5 square meters. We'll find the total area of everything that needs to be painted on this, and then you divide it by 5, and you'll get your answer. Okay, so hopefully that helps you out. See you in the next video.